Hello everybody, welcome to the Weldment seminar. Today we're going to be covering the Weldment packages inside of SolidWorks. Comes with your basic SolidWorks package. As usual, I try to plug my own group at Go X Mechanical. Under training and tutorials, we've actually already got sheet metal in a Weldments class that were done a couple of years ago. There's a lot of good information. I'm going to be covering some of the same information in this example, but I'm also going to be covering some new information as well. Another place, if you're looking to learn more about weldments, SolidWorks has a great tutorial setup. I go to the help, go into the tutorials, I look at all of them. There's actually a couple of tutorials on making weldments. So those will take you through step by step. It's always a great idea to actually get your fingers clicking around the user interface so you know what's going on. But without any further ado, let me get into the presentation. So I'm going to start just a regular part here that I'm going to draw a shape in. First off, start with a couple of rectangles. Go into a line tool here. Draw myself another shape. I'm making sure that I don't hit the midpoints. I always try to point out what I'm doing here for time savers. If you're drawing a line and you want it to be referencing another line automatically, while you're drawing it, if you touch that line, you can see that now I can have this automatically be parallel to the line that I was starting with. Also in 2019, you'll see that once I've completely closed the gaps, then it fills in the area with shaded if I've got a closed contour. So now all I need to do is put in some parametrics and some dimensions. I want to make sure that these two plates are the same size. And that size is 1/2 inch. And then I'm going to start putting in the dimensions that I need for the overall height. Width, the angle in here. Move this to a spot where I can place it in there. If you put dimensions between those parallel lines, it'll give you an offset distance. Okay, so it looks like we've got this thing pretty much planned out. Maybe one more dimension to locate where exactly that gusset is. There we go. That looks like the side of the part that I want to do. You'll see that I have multiple contours here. So if I go into my extrusion tool, while I've got a sketch like that, it's going to ask me right here to select contours. Anytime you see a blue box inside of the property manager, that's letting you know that SolidWorks is waiting for some data input. So I'll pick this face, do a right click and switch the end condition to midplane, and then drag this out a few inches. Closer you get to the scale, the more accurate it is. So there we go. That's my first part of this weldment. Don't be alarmed if the sketch has gone away. SolidWorks always hides the sketches, but you can expand the feature in the feature manager tree. Select that sketch again. I'm going to extrude this piece. Same size. Notice that SolidWorks automatically wants to merge the results on everything. So what happens is I end up with one single solid body where there's no seam in between these. Let me go back into this extrusion, edit the feature, and I'll turn off this checkbox. It's on by default, this merge results. And you'll see that when I do that, it actually keeps the two pieces as separate bodies. And so I can work on one and not affect the other. And this is the beginning of that whole weldment idea. Doing a weldment in SolidWorks is really just multi-body design is all it is. You'll see there's a weldment tab up here on my property manager. If you don't see it, you can always right click and turn that tab on. And I'm just going to press this button here. notice that it's keeping track of the bodies, but when I press Weldment, a couple of things happen in my feature manager tree. The first thing is a little icon appears that says Weldment. The second thing is where it used to say solid bodies, it now says Cutlist, and it gives me a count on how many bodies I have in that Cutlist. All right, let's go back into that sketch. I'm going to extrude it one more time, and this time the contour I'm after is this gusset. I want to start it on this surface, inward, 1/4 of an inch. And you'll see that because I've pressed that weldment button, because this is part is now considered a weldment, the merge result is automatically cleared off for me. So not only does it start keeping track of a cut list for me, but it also has that merge result turned off. So I don't have to keep clicking that myself when I'm extruding things. It automatically creates multi-bodies unless you don't want it to. I'm also going to mirror this body. And there we go. That is my first weldment. You'll see that it's got a cut list with 1, 2, 3, 4 separate bodies. If I right click on the cut list, there's a choice to update. You can actually have this set to update automatically, so anytime the part rebuilds, it will regenerate the cut list. But what the update does is it tells SolidWorks to take a look at all of the bodies that I have in this part. And it does a quick geometry check. If any bodies have the same exact geometry, like these two gussets, they end up getting grouped as one item with a quantity of 2. Let's take a look at these a little more closely. If I right-click any of these folders and go into the properties, you'll see that it'll list properties per cut list item. I want to have a property called description. I can use this pull down since I'm terrible at spelling, and I will say that this one, okay, is my base plate. Hit enter, you'll see it assigns that name. So this first tab, the cut list summary, I can go item per item and add any descriptions. The second tab actually shows me the different metadata that's assigned. So you see under description, only one of these has had that property specified. So I'll go through in here. Let me take a look at my model. See that it highlights the body that I'm on. So that is my back plate. And then this is gusset. So now I've given everything a description. If I go in here, each item has a description. Second page shows me each piece of metadata and any value that's typed in. This last one actually shows me the cut list that's going to be put into a drawing when I make a drawing out of this part. You can see that the description is already filled in, so is the item number and quantity. The length is blank right now. When we start getting into using cross-sectional members, like pipes or square tube or something like that, SolidWorks will actually calculate how much of that pipe or how much of that tubing you need to create your model. Let's say okay. I'll hit save. Save this out just on my desktop as weldment example. All right, so I make the save to my drawing or my model here. The next thing I want to do is make a drawing out of this. So let's make a drawing from this part. I'll just pick a blank drawing here, make it an A size, no sheet format necessary. All I wanted to do is really show you the basics here. You'll see that a weldment comes in just like any other part. I can drag and drop. Since I've got my auto project started up, I can quickly click and drag a couple of different views. The first thing when it comes to weldments is putting in a cut list. So I showed you how to set up the properties that go in the cut list at the model level. At this point, once I'm in the drawing, I can just right click, go to tables, and ask it to show me that weldment cut list. There's the cut list, just like promised. You can rearrange these. In this case, the length doesn't really make much sense. You can change this to read off any property, just like when you're in a bill of materials. Same idea, where I can set this to use, the material that the item's using, or any other defined item that I want to put in there. If you don't want to have it in there, you can just right click on the table. Try that again, right click on this column. And I get a choice to delete the entire table or just the column. I'll just delete the column. There we go. So this acts just like a bill of materials. When I click on a drawing view and I ask it to auto balloon, the balloon numbers that it comes to are going to be the corresponding numbers that we've got on our bill. So item 1 is the base plate, item 2 is the back plate, item 3 is the gusset. If I was to rearrange these or anything, those numbers would change as well. You can also put in, just like with a regular balloon from a bill of materials, a quantity in there if you want. So pretty nice. I can tell them how many pieces I need and a corresponding table to give me all the names for them. And then this is truly a weldment, so I need to tell them how to weld it together. I'm going to show you in the next example how to put in weld beads as features inside of your part, but it's not necessary. You can just put in weld symbols as if they're annotations in a drawing. A lot of times that's what people do here. So you pick an edge that you want a weld symbol to be on, and then it opens this window. So you see you have different spots that you can do field all around. If you put any notes in here, it'll automatically put that flag on the end. When it comes to what weld do we want on here, so the weld that is on the bottom, that is the close side to us. So I want to put in a fillet weld, and you can put in the size of weld, any spacing or numbering in here. So you see that it gives you a lot. You can even put in second fillets if you want to start building in a stack. Again, if you click the weld symbol, it takes you to the library. You can call up more symbols, but this is the default ANSI package that it comes up with, or the ISO package, depending on what you've got your standard set to. So I dial up what kind of weld we've got here, and you'll see that it'll put that information in there for me. So again, it's just note to note. Pretty easy, just fill out the information that you're after, and then you've got a weld symbol. If you don't select a place first off, you can just click it. It'll put it in there. If you do place it without putting any information in, just double click on that weld symbol and it'll bring the information back up for you. Or you can fill out the values that you're after. And so now someone not only knows what pieces they need, but they also know where they're supposed to weld and how, which type of weld they're supposed to put in there to get this thing to stay together. So that is really the quick 15-minute tour of the basic weldments. It's a multi-body design. SolidWorks will automatically do geometry checks to give you a quantity count on those multiple bodies. When it has similar bodies, it just gives you a quantity count of 2. And then that can be accessed just like a bill of materials. All right. If there's no questions, I will continue on here. give away the ending here. Let me open up a new part. And I'm going to do some tricks. People like when I show them, you know, how to work faster. One well-known trick is if you see a plane and you hold your control key down, click and drag the edge of that plane, it'll give you an offset plane. You can put a value in there. Once you've got a value assigned, you can actually assign it to be a global variable right on the fly. If you put equals and then in quotes, whatever you want the name to be, how to create a global variable on the fly. As long as you say yes. If it says no, it'll take you back into modify. But let's say yes, I do want that. And I can either see the name of the value or the value of the variable itself. I can even do math in here if I want this to be half the width. I can do that. Now that actually has a little sigma in front of it because it's going to calculate that every time I rebuild. So you see if I rebuild, moves it in to just half of that. If you want to change the equation, it's right here. If I right click and say manage equations at any time, I can fill in this value if I want the width to actually be 18. Do that. Where'd my cursor go? There it is. Okay. Sorry about that. All right. So now the width is 18. I'm going to do another offset. So again, I hold my control key, click and drag the edge of the plane. Unfortunately, you cannot type the values in here. You have to place the plane first. And then when I edit the value of it, I can put in that global variable. If it's already been assigned, when you type in the equal symbol in your modify box, it'll give you a list of global variables if you've already got a bunch assigned. That's a pretty cool trick as well. So let me just rebuild this. Now I've got one that's half the width and another one that's the full width of the step stool that I'm going to design. So in the middle of this, what I'm going to draw here is I'm just going to draw the shape of this step stool that I want. A little two-step step stool, nothing too amazing here. You know that if you, as you're drawing a line, you follow those yellow lines, it'll automatically place permanent relations on there. While you're drawing a line, if you go back to the beginning, it'll start a tangent arc. You can also toggle that on or off with the A key on your keyboard. It's kind of nice to be able to go in between arcs and lines without actually having to change tools. I just need to make sure everything's square and lined up here. So I'll put on a couple more relations. Start putting in some dimensions so I get a better proportion on this thing. Another trick is if you're dimensioning, say off of a plane or anything, off of a point, and you want to hit the top of the circle, by default, if I click on here, it's going to go to the center of the circle. But if I hold my shift key, when I pick that, let's try that again. Yeah. Pick a point, hold my shift key, pick that arc. You can see that it wants to do the max distance for me automatically. And that's if you hold your shift key before you pick the arc. While you're selecting the arc, you want to have it held down, and it'll automatically figure out that you're after the full distance here, rather than just the center to center distance. Keep putting in my dimensions here. I fully define this thing. I want to put a dimension in here. Well, two things. I noticed that this edge doesn't really meet up. It's not going tangent to it. Something that's new in SolidWorks, you used to have to pick the line and the arc to put in a relation between these, but now if you pick a point, you can make it tangent right away. You see that fully defines my shape here. All right. And the next thing I want to do is put in a dimension here. I'm worried about the angle that we've got going on here. So you'll see that this is free to move here. I want to put a 45-degree angle in there. Another new thing with SolidWorks, if you are picking a line and then you pick a point, you'll see these little arrowheads appear if you pick one of the vertexes of the line. What that allows me to do is that allows me to put in an angle dimension without having to put in a plane or some other type of reference geometry to measure that angle off of. Okay, that's looking almost right here. I got one more thing I want to do. I want to put in a little cross beam at an angle. Again, if you need to relate it to a line that's already in your sketch, just touch that line. There we go. You'll see that I can get things like a parallel relationship. I'm going to select on this. This is always going to be parallel to that line now. I just need to tell it, you know, where the ends of it are, which is here. And then a distance below. Now I've got a fully defined sketch that I want to use as the two sides of this stool that I'm designing, the step stool. I wanted to talk to you about a couple of different ways to copy sketches. A lot of times when we're doing weldments, it's going to be the same sort of frame over and over again. Maybe you want to use that again. There's a couple different ways of doing it. If I start a sketch and my sketch plane is parallel to the original sketch itself, it's pretty easy. I can just hit convert items and it'll convert that entire sketch. If anything changes in this original, that will update. But be aware that it's projecting it. So it only works if the plane is parallel. If the plane is at an angle, your circles aren't going to be circular. They're going to be elliptical because they get stretched out or foreshortened when that angle is changed. If you want to have a true copy of a sketch on a plane and not have to worry about that foreshortening, there is another way of doing it. If I select a sketch, hold my control key and pick a plane, so you need to have those two items selected before this option becomes available, there's a choice called derived sketch. So what derived sketch does is it makes an exact copy of that sketch. It's just not located anywhere. You can see that I can drag it around. If I were to lock one point down, I can put it at a different angle, but it's always going to be the same exact size and shape, truly. All the circles are going to be circular and things like that. So it's a little bit more powerful than just to convert entities, because it is a true copy of the sketch itself. But I just wanted you to be aware of what was going on when that happens. You see with the derived sketch, if I do locate it, and I do something like I give it an orientation, I actually want it oriented parallel to these originals. There we go. You see that it turns fully defined without a single dimension because it is the same size and shape of the original sketch. All I'm doing is giving it a location. There you go, a little bit about copying sketches. This one is a derived, converted sketch. This one is derived. If at any time you want it to not be an exact copy of the original, you can underive it. It becomes its own independent sketch. You can put dimensions in it. It will not affect the original. Be aware that there is no rederive. Once you have underived a sketch, that's forever going to be the way it is. It just turns it independent. So be careful before you underive it if you don't know what that means, but just to let you know what's going on there. Any questions? All right, then. I'm going to hide this original sketch because that's not actually part of it. I'm going to put in a 3D sketch. Now, 3D sketching happens a lot in Weldments. In fact, on my Weldment toolbar, 3D sketch is the first button. A sketch does not have to be 3D to be Weldments. You can have a series of 2D sketches. You can have a combination of 2D and 3D sketches. It's just that the 3D sketch allows you to draw lines that are not on a single plane, obviously. They can go on any plane. So if I open up a 3D sketch and I want to draw a line, once I'm in the tool, you can see my cursor says XY right now. So when I click on a point, that little red L is oriented with this XY plane. So you see I can go along the Y or the X. It doesn't have horizontal or vertical because those don't really make sense in 3D space. If this is going in the wrong orientation, you can hit your tab key. And if you notice that little red L just changed, so did the symbol next to my cursor, letting me know that I'm now sketching in the YZ orientation. One more hit gives me the ZX. So it just toggles you in between the different items that you want to do. You don't necessarily have to be in any particular orientation. You can lock a sketch down with geometry. You can also click on it, add relations. Like if I want this to go along the X, I can do that. And now I know that this thing is going to be parallel to the top plane. You put dimensions like in any other time in your 3D sketches. It'll figure out the orientation of the dimension from the selection that you make to your sketches. So this is the plan for my steps tool. What I want to do is fill this up with structural members. So I showed you the 3D sketch. I showed you that any time in a multi-body you can press that weldment button and turn a part into a weldment. But a way to automatically create a part into a weldment is just to use the structural member feature to create your first solid geometry. What the structural member tool does for you is it takes us into a library. In this case, I've got an ANSI inch library, and this ships with SolidWorks. Very, very truncated. Just a few cross-sectional shapes, and inside of those shapes, there's just a few different sizes. I'll show you where to get a complete library a little later, but for now, let's say we want to make this out of square tube. Then I want to dial up the size of square tube that I've got, so I'll do 2 inch by 2 inch by 1/4 thick. And now I highlight the groups that I want to do, and I can select items that are going to be a continuous item here. When you are going around a circuit here, where you've got line, arc, that sort of thing, you have a couple of choices. This merge segment bodies, if that is checked on, this is going to be one piece of bent pipe. If that is turned off, this is going to be 3 sections of straight pipe and 2 elbows. So it really depends on the manufacturing process whether or not you want to merge the arc segments. If you're using elbows, you would turn that off. But in this case, we're going to leave it on. You can only do so much in one group. You'll see that it's not letting me select too many other items here. It only selects items that are on a plane or parallel to one another. Once I've started over here, this is on a different plane, so it's not letting me pick it. I just need to say, let's start a new group. And it'll go with the same size cross section. When you're working inside of one particular bunch of groups like this, you'll see it keeps track of the groups. They're always going to be the same size. If you change the size of your cross section, it changes the cross section of everything in that feature. So I can pick some of these at the same time because these two are on the same plane. Notice that SolidWorks will trim these up to one another. Even though the line goes past the edge of this part, right where they meet one another, that's where SolidWorks is going to trim them together. So when you're using multiple groups, the groups will trim to one another. They're always using the same cross-sectional shape. It also is going to trim right up to the face, if it can. You can put a weld gap in there. And what that will do for you is put that gap in there for you if they run together. Okay, continuing to move through here, I can pick group after group. And again, they'll start trimming up to one another. The real great thing about this is the ability to change, because I could obviously model these with sweeps. But if somebody calls up and says, hey, we're going to make this thing out of pipes instead of tubes, if I had done it as individual sweeps, I'd have to go in and change a lot of sketches. Here with a weldment, I can just dial up the other type of material that we're using. And you'll see it swaps all that out for us. And it even does, you know, the trimming and the cutting back to the new shape. Okay, so I'm going back to the 2-inch square tube here for a second. I'm also going to add my last group here because we need a piece that bridges the gap. And there we go. That's the start of my model here. There's some other items that we can put in automatically besides weldment items. Like one of the popular ones are end caps and gussets. Got some tools right here. If you want to put in end caps, what you need to do is pick the end that you want to cap off, or ends. You'll see that it'll start putting in a cap for you. By default, these will be smaller. Right now, they're a half a thickness ratio of the model, of the cross section that they're going on to. So that 1/4 inch thickness of the pipe gives us an 1/8 inch offset here on either side. Also, I can break the corners if I want to have chamfers or fillets on there. You can also have no offset if you want to have it right up to the edge of it. The other settings on this end cap is the location of it. So by default, it's doing outward, which means you pick the face and then it goes this distance off of that face. Now, if I had measured my sketch counting the end caps on there, this is not what I'd want because this would be a 1/4 inch taller than I had originally asked for. The other two choices that we have don't change the altitude of this thing. So the first one, what it's going to do is it's going to trim back a 1/4 inch and then it's going to put the caps on. This other choice actually puts plugs inside of there for me. So same height, and it's to the inside. All right, so a few different settings you can do on the end caps. Another popular one is a gusset. When you're trying to put a gusset somewhere, if you pick two faces, you'll see that it'll put a gusset in between those two faces at whatever angle those faces are at to each other. Here's where I can crank up the thickness of the gusset. Also, is it going to the inside, the outside, or right down the middle of that flat is what these choices do. Also, whether I'm measuring the thickness to the inside, the outside, or the middle is set up right here. You can do different shaped gussets if you want to break it off or have a gap in the middle, things like that. You start filling in these dimensions, get yourself a different shaped gusset. For just a regular angled one, put it in like that. Any weldment body can be mirrored. When you mirror these types of things, typically it'll go right to the bodies. If this was not a weldment, it would have opened the features to mirror. But because I'm working on a weldment, it automatically says, what body do you want to mirror? You can tell that's highlighted blue. So you can also mirror and pattern any weldment bodies that you want to use over again. One more shape that I want to do here is a step. It is a step stool. So let's go ahead and build ourselves a nice rectangle. And I'll just put in the values of how thick and wide we want this thing to be. And then also, oops, too many zeros, I guess. All right. The other thing I'm after is where the location of this is. I accidentally put it somewhere, which I didn't mean to do. So let me just delete that dimension and try and get this thing back a little more. You can dimension to the weldment sketch that I was using earlier. Then I just need a height on this thing. To get it located. So I can extrude, obviously, if I go up to the surface. Because I'm in the weldments, this merge results is automatically turned off. There we go. I've got another solid body. I want this one to be a piece of sheet metal, though. I do have an older sheet metal posting and a new one, so please check out the sheet metal. It's a whole other entity to itself, but a lot of times sheet metal and weldments go together. So I was just going to quickly build this step. So I created the box shape that I wanted. And with this convert sheet metal, I can pick a face. Here's where I fill in whatever I want the gauge to be and the direction that it's going to be. By default, it's going to get rid of the solid body that I'm working with. If I wanted to keep that rectangle, that block for some reason, I could turn that on. The other options I can do is I can pick bends that I want to have. You see that these will bend up nicely. Say OK. Now I've got a sheet metal part. And with that sheet metal part, I can put other sheet metal features on it. I want to do an edge flange. Put a mitered edge around the box here. Give it a little bit more sturdiness. There we go. The sheet metal also, it is just another body, so I can choose to do a linear pattern. This body. Just tell which direction I need to go. And there we go, a couple of stairs. I'm going to update this again. Remember, you just right-click and update, or if you turn on update automatically, it'll always do that for you. And let's take a look at what we've got here in our cut list. If you see, some of these items have this little weldment symbol right in front of them. Whenever a cut list item has that symbol, what that means is it's using a cross-sectional shape. It's using a weldment structural member. When you've got a folder like this, that's something that's been extruded, where it doesn't have a cross-sectional shape. It's not an I-beam or a piece of pipe or anything like that. So those gussets and the end caps have been grouped with those folders. And this last symbol right here is showing me that that's a sheet metal part. So the body itself actually has sheet metal capability, where if I pick on this body, if you bring up my sheet metal toolbar, right click, sheet metal. I've got this choice to flatten. If I pick on the body and hit flatten, I can see the flat pattern. It's a little hard to see with all these other sketches, so if I hide them, you can see it more clearly. There we go. So when I flatten the sheet metal, I get a couple of sketches showing here. One of them is the extent, the size of the box is the biggest slab of metal that I would need cut out of that sheet to make this shape. And the other lines are actually the bend lines. SolidWorks calculates the amount of stretch and everything. So when I flatten it, it actually stretches the metal. The flat pattern is a little shorter than the target. So you can see that it qualifies what type of cut list item it is, and also groups them. You can see that I have 2 stairs, I have 2 gussets, I have 4 end caps. If I right click and go into the properties of any one of these, you can see that when I go to the cut list table, anything that's using those members, it's actually giving me a total length that I need of those for that item. So I need 2 17.9 inch long square tubes, as well as 2 17/13s and 1 16. So it gives me all the pieces I need and the length that I need to cut them. You can see that descriptions are not available on stuff that's been extruded, or whenever it's a sheet metal part, it just says sheet. So of course you'll have to go through for those, go into the description, and put in whatever values you need. Again, it's a good idea to highlight this so you see that, oh, it's highlighting 4 items, so those must be the end caps. So we can put whatever we want in here as far as the name that's going to show up. And then when we go to our cut list item, I can start filling it in with those names that I've asked for. Another thing that you can do is you can put in weld beads. There's different types of weld beads you can put in. You can put in weld beads actually in the sheet metal on the corners of this. You just pick the corner and hit welded corner. Or in the weldments themselves, you can put in these weld beads. I typically don't put in the corners on the sheet metal just because they don't show up in the same sort of location that we get when we put them into the weldment, because I can actually get a table of these printed out later on. So you see that when I pick faces, You put a weld bead in there. You can also pick a series of edges. Pretty easy for me to right click and select tangency on this thing. When I put my weld bead on there, here's where I can set up what type or what size weld it is. Oops. Sorry, I have to set it up to be on a weld path here rather than between two pieces of geometry like I was doing earlier. So I'll select tangency. There we go. This is where I fill out what size of the weld I want it to be, and if I have some other symbol that I want to do besides a fillet. It defaults to a fillet unless you tell it otherwise. But these are good because you can start seeing, you know, issues like if your weld is actually going into, you know, messing with your head clearance, or you're not going to have space enough to put in that weld, those sorts of things. So I've already got an example here of this step stool where I put in all the welds that I need. So I went through, picked all those edges that I needed. Here's one of those corner welds that I was talking about earlier. If I were to edit it, you'll see you can pick the faces that you want to close up the gap, what type of weld you want. And I'll put that weld on that piece of sheet metal. Of course, whenever I flatten that piece of sheet metal, those weld beads disappear. It only shows up on the folded version. Okay, so I put in weld beads. I put in all the items that I need on here. I want to create a drawing for this as well. Just like in an assembly, if you want to have an exploded view of a weldment, you're going to have to do that at the file level. You can't do it inside the drawing. So if I go to my features, I'm not seeing the feature that I want, so I'll use my trusty command finder and say, okay, let's do an exploded view. It's the same exact tool that you use when you're exploding an assembly view, where you can pick multiple items. All those go at once. You can pick single items. Start spacing this thing out however you want to do it. So it's similar to an assembly. You just pick on the part that you want and start grabbing and exploding all these pieces. It ends up giving you an exploded view in your configuration manager. You just double click, it collapses, and double click again, explodes. So it works just like an assembly explosion, only you're doing it at the multi-body level. With that, I'm going to make a drawing out of this now. I'll create a brand new one. Just an A size. And as usual, I'll get a projected view. I can make front, top, right, ISO pretty quickly. But if you have an exploded view, you can drag and drop it just like you drag and drop an exploded view in an assembly, where either you can use the isometric exploded view, which will come in as a choice for you, or you can bring in any view, go over here, tell it to show it in exploded state or not. But you do need to do that at the model level first. Maybe we'll explode this view here, get it onto my page. Going the wrong way. There we go. All right, and probably don't need to see those sketches. There we go. Again, this is going to allow you to auto balloon on this. It's going to take the balloon numbers from the cut list. So if I choose to do it before I put the cut list in, it will ask me to insert one. So I'll put in my cut list. And then I can auto balloon it. One more thing that I can put in here, besides a cut list, is if you've gone and taken the time to put in all of those welds like I did a little earlier. Let's do a quick copy of the sheet, paste it in there. So that first one gave me the bill. The other one I can do is I can put in any types of annotations, so any weld symbols that I put in there. I want to make sure that I do it for the entire model and all views. There we go. Put in a lot more than I thought it was going to, because I didn't turn off any of the dimensions. It put in everything for me. But you can see that wherever there are welds, it'll put in these little caterpillar marks for you. You can choose what shape you want for your caterpillars here in your property manager. Also, so we've got all the welds in there. I put them physically in there so I can see them. And I can also call out all those annotations at once. Probably this is way more than I need. A lot of times people would just put in, like a TYP instead of putting in every single weld. I kind of let you know we're after 1/4-inch fillet welds on this thing. You can also, especially if you have a bunch of different types of welds, you can put in a weld table as well. So if I right click on here and say, let's give me a weld table. Here's the 5 different types of welds that I've called for, what their length is, and the quantity of them. So putting in the weld symbols, again, a lot of people just put in the annotations like I did on my first example. It's a lot faster. But if you want to really take the time to figure out how much welding it's going to do, if you're trying to figure out the time it's going to take, or maybe the weight that it's going to add once you put in all these welds, you may want to put in that weld beads, because you can add a material, you can figure out the volume and things like that. Also, I'll put in one more page here because I wanted to talk about the individual components inside of this. So I did a bunch of different parts. I've got the 2 main bars, I've got some cross beams, gussets, end caps, things like that, but they don't have their own file for me to make a drawing view of. You don't have to make a drawing view of the entire file. I go into my view layout, say let's do a model item of the step stool. By default, it wants to do the entire part. Turn on my graphics preview. There it is. That's the whole part. I don't want the whole part. I just want to take a look at maybe one of the sides, what angle these things are cut out, the flat that I need for the sheet metal, those sorts of things. So I can say, okay, let's select body. It'll take me into the model that I was working on. And I can say, I would like this to be what I'm making a drawing view of. And then when I'm picking my views, preview's only showing me that component because that's all I'm going to end up. It'll project it just like any other view. So we can do body by body, bring out what each component is, and make detailed drawings of what we need this thing cut to or what we need to bend to. How wide is it? How tall is it? What's our inside bend shape? Things like that that are going to help people manufacture what we're after correctly. So this one was really easy because it was at the correct orientation that we wanted to have the assembly done at. I'm going to do another drawing view. And this time I'll do a different body to select. I'll select this one. When you're dealing with the sheet metal part, in the drawing views, it'll automatically have a choice for a flat pattern. So because that item has that little sheet metal symbol next to it, SolidWorks realizes that this is a sheet metal part. So I can get a flat pattern of it. I can also make a three-dimensional view of it. When you're picking the sheet metal part, when you choose flat pattern, it creates a configuration of it as it is flattened. Try that again. Okay. So there's configuration with it flattened, there's a configuration with it folded. So I can show both of those. It really just depends on which configuration it's showing as far as which piece of sheet metal it's going to display on our drawing for us. Okay, one more here. Let's do a trick. It's called a relative view. When you create a relative view, what you're doing is you want to tell it what you consider to be the front, what's the top, what's the right, however you want to define it. So I can say, okay, in this case, that's the front of the part, but the top of the part is this. Now it'll take me into that view where it's dropping the entire part in, but it's in that orientation. I can say, okay, I don't need the entire view. I just need this part. And there we go. I have just that item in true size and shape because I've got it at the correct angle. It's not at that 45-degree angle that I had before. So I can put annotations in, that are oriented correctly on the page for me. So we can tell them how long we need this to be, and what they need to cut these to get it to be at the right angle for us when we place it in our assembly, or weld it into our weldment, I should say. So, okay, those are really the basics of weldments. Using your weldment tools, create sheet metal in there. You can even extrude any shape you want. It's just a multi-body design, and you're able to grab information like a weldment cut list is automatically set up for you. Getting a weld table like this, you have to set up those welds ahead of time physically in the model. Same with if you want an exploded view, you just set that up physically in the model. All right, so that was the first hour, which was just covering the basics of things. I'm going to get a little bit more into details as we go on here. All right, not all weldments have to be something that is welded together. If you take a look at this assembly right here, This is a bunch of different weldments, but it's made out of different materials, whether it's 2x4s or, you know, square tubes. You can put these all together, whether they're nailed together, fastened together, welded together, doesn't really matter. All we want is to get a multi-body design that gives us a list of what's inside that design. I'll pick on this item, hit my D key. It's not letting me do the D key because I don't have this thing fully, it's in large design review, so I just need to open this assembly. From here, let's take a look at one of these deck pieces. You can see that this thing's made out of a lot of different structural members, boards, planks, that sort of thing. When you have a sub-assembly, so this is an assembly that includes weldments. When that's the case, if you are to do a bill of materials and you do an indented list, has to be an indented list, the part has to have weldments underneath it for this trick to work. But if I create that bill of materials, I'm just going to drop it in at the assembly level here. You can see that it actually comes through and starts giving me the roll up on the total amount of 2x4s I need here. You know, if I open up this dock, it's going to have 15 different sizes of 2x4 that I need and different quantities of that. This is all the 2x4s added up and summed together. It does not do board feet for you, so if you're wondering how many 12-foot 2x4s would I need to make this happen, you're still going to have to do the calculations on it. But it is going to give you a ballpark if you're going to need a total of 504 inches of 2x4, and then you can start figuring out how you're going to cut the boards to make the individual pieces yourself. So let's build a non-welded weldment. I'm going to make one out of preform. It's similar to PVC pipe. It's just plastic tubing that people make, shelving units for, or what they call lean cabinets or carts, where you're going to have all the pieces that you need to make stuff at some location. But you make this design out of pieces of tube. What I'm going to do first, I'm just going to quickly draw the shape that I want. Being sure not to hit any midpoints or anything by mistake. Okay, and I'll start fully defining this thing, get it all squared up to the world. Give it some size. All right, this should make it all fully defined. Okay, perfect. So this is, if I'm looking at it from the side, I'm going to have a little counter and it's going to have a shelf on top of it, is the sort of basic shape that I'm after on this thing. It's going to be pretty long, but I'm going to use a tool here to help me lay this out a little easier. You saw when I did the step stool, at first I created reference planes, put my sketches on those planes, trying to give myself, the shape that I was after. But there is a tool that can do this for us automatically. It's called a grid system. So So if I pick a grid system, actually, it put me into a sketch. So if you just pick the grid system automatically, it will open a sketch for you where you're supposed to draw it. If you already have the sketch drawn, you should select it first. Let's try that again. If you have this pre-selected in the feature manager tree, it's just going to use that sketch I already had. Here's where I can put the amount of stations. So right now I have 2 different stations and they're 1.7 meters apart from each other. You know, if I double click in here, I can put a third. I can put as many spaces as I want in here. This is good. I'll just do 3 stations with that spacing. And right away, what it does is it gives me planes or sketches on those spacing that I asked for. It's set up more than that. Not all of it is shown for me, but it's set up 2 planes for me. It also does a 3D sketch, which pretty much connects the dots for you. So I get all these lines here where it's going from whatever vertexes it can find and just shooting a line to the vertex the next station down. It also puts this series of surfaces here for me. So if I show these, I can see the outside of this. And I can actually sketch on these if I need to. So it's a really useful setup tool to quickly sort of flesh out, this is the shape that I'm after. I can also use those surfaces for reference geometry. So I can create midplane here. Or midplane. Yeah. There. So all I'm doing is if you're in the plane tool and you pick 2 faces, whether they're planes or surfaces or whatever, it just puts the median in between there for me automatically. So there we go. I've got some mid planes. I don't need to see all the surfaces anymore. So I've got a pretty good setup on, you know, the box or the extents that I want this thing to be in. So this is multi-body design whenever you're dealing with weldments. So what I'm going to do here is I'm going to model as separate bodies the different connectors that I have for these creeform tubes. So for this one, I'm building like a 3-corner elbow. Oops. 50 is good enough. So far, this is not a weldment, so it's not trying to separate things for me. It's going to merge them automatically together, which is what I'm after at this point. So I'm working with this as a solid at the beginning, just for expediency, so I don't have to keep telling it to merge. It's just automatically doing that for me. Not enough thin wall thickness for me. Let's try that. There we go. So that's what this elbow looks like. I'm going to do another one. If I Sketch. All right. All right. For this one, I'm also going to extrude it. Choose where to extrude it off of this plan. All right, I'm going to do a circular pattern. There we go. Axis, this body. And one more should do it for me. Right, and then I just shell them out. So these are connectors that you can purchase from the Creeform company. They have all different kinds. So I've just made a couple of them that I'm going to need. And there we go. So the reason that I put in these mid planes is because this thing has a lot of symmetry that it uses in here. Oops, I messed up one of them. There we go. I just noticed that the mid plane I should have done. There we go. Okay. All right. Now the reason I was doing that is because a lot of these are going to be used over and over again. So I can just mirror the bodies that I need. Get myself the elbows on the other side. To get those that I need up here at the counter level. So most of these I'm okay with just repeating because they're actually in a location that's pretty easy for me to mimic using these planes. But some of them I actually need in a different location. So I'll show you something to do with multi-body design. There's this command called move copy. So it can do two different things. It can move or it can copy, like the name would suggest. When I have it set to copy, the only thing I can do is translate or rotate these. So I want to make some copies here of several of these items. Just drag it to the approximate location that I need them in. So now I've got more fasteners than I had before, or more of these connectors that I had before, but they're not in the right location and they're not in the right orientation. Let's use that same tool. If I turn off the copy, I have the choice to do constraints as well. And what constraints allow you to do is you can pick which body you want to put constraints on, and then you can start mating it just like it was a component inside of an assembly. If it's going the wrong way, you can flip the mate alignment just like you can at the assembly level. There you go. This is one of those strange tools that does not actually, the enter key does not let you repeat the last command like usual. So just be aware of that. But as you can see, I can start getting these things located into the location. So I just need to tell it which body I want. And then I pick geometry. And it'll try and solve that for me just like it would with an assembly mate. One last one, moving this guy. Sometimes it doesn't move because it's already pretty much in the correct location. But it will move if it has to change the location of the item to solve that mate. All right, so I'm starting off here. I've got a pretty good start. Those are all the connectors I need on one side. I'm just going to mirror this thing when I'm done. So I'm only going to build one side of this. Again, I always try and take advantage of symmetry whenever possible. Let me quick save this because I also like to save stuff whenever possible. Just gotta call this the new rack. Got my caps lock on. Now I told you I wanted to put a preform cross section in here. So if I go to my weldments and I dial it up, if I say I want to put in a piece of pipe, there we go. Okay, that pipe is too small. That pipe is too big. I don't have the right size pipe. In fact, this is wrong any way you slice it because it's supposed to be a creeform shape, not a Schedule 40 piece of pipe. SolidWorks does allow you to cheat, as usual. I can go in here and I can actually change what the size of this thing is. When I rebuild it, figure out which size it's going to be. So what I want to do is I don't want to change this dimension because even though I've changed this, I got the wrong dimension in here. It's supposed to be 32. There we go. Now it fits in like it's supposed to. However, this item in my feature manager tree still says it's a Schedule 40 piece of pipe. The Cutlist also, when I update it, and go in the properties, it also thinks it's a Schedule 40 piece of pipe. So cheating is not good. You should already know that by now, but just because SolidWorks allows you to do it doesn't mean it's necessarily the best way to do it. So it's not a great idea to bring in your weldment cross sections and then play around with the cross sections. It's a better idea to make your own. So there is certainly a format that you need to follow. And what you need to have is you need to have a part that just has a sketch in it. I'm going to start a sketch, and I'll draw a couple of circles here. I want this to be 32. This to be 2. That is what the cross section looks like. When you are placing your cross section, you'll always pick whatever this origin was in your sketch for the line that it's going to draw it along. If you want to give people the ability to select like the edges of this to run the pipe down, you need to put a point in there. And then that point can act as a location that you're going to run the shape down. Or if you just have anything that has vertexes, you know, if I have construction geometry, these points can also be used to locate where that pipe's going to be placed. I'll show you these in just a second here. So I'll make those guys tangent, and all of these equal. There we go. That is my shape. And now I can not only run this thing down the center of the tube, but also when I'm running the tube down my sketches, I can do it at any quadrant or at these corners here. Okay, so that's my sketch. I'm not out of the woods yet. I still need to place this in a spot where SolidWorks can locate it, so it has to be in my Weldment library. Also, I need to save it as a library feature part. First thing when you're creating a library feature part is you have to tell it what part is the library feature. So it's that sketch. I highlight the sketch first, then I go to File, Save As. It wants to save it as a part, but I can switch the type to library feature part. The place I need to save this, I'm going to save it into where my current Weldment profile are. So that's under my C drive, SolidWorks Corp, SolidWorks, Lang, English, Weldment profiles default. I've actually created a folder here. So you need to create a folder if you have any new standards that you're going to do, and then any subfolders. So if I had like H400, H600, I could do each one of these, and that would be a sub classification. Like when I went into ANSI inch, I could pick pipe or square tube because there's a folder of pipe and there's a folder that's got square tubes. I need to save it inside here. So I'll save this as 28 mm. Okay, it gives me a little warning. It says, hey, this is only going to save the library feature that you did. And you can tell if you got it right two ways. Up here, the very top of your feature manager tree should look like a set of books. Down here, in front of the icon for the sketch, there should be an L, blue L, placed on that sketch to let me know that that is the library feature itself. So that's how you create a Weldment profile. When I go into my structural members, I just need to select that standard. Then I have the subfolder that's in the standard, and then the different sizes I can choose from. So when I start creating these, I'm going to know that they fit in there perfectly because they're based on the actual preform size that I wanted here. So again, I just need to do new groups. If I've got something that's not really connected or SolidWorks can't figure out how the connection goes, you can just start another group. All right, and one last one, I think is all I got right there. Here we go. Okay, if you miss one, you can always just right click and edit feature like this, like on any one of them. If you have a particular group you wanted to add it to, you can highlight that group first. If you don't, you can just start a new group as well. And notice that when items do come into contact with each other, you can choose, how they're going to come up to each other. Do they butt up against each other? Do they form a miter? That sort of thing. That'll actually cut the end of this to the other pieces. There we go. It's still a little hard to see because I got all these surfaces. Let me just hide that surface folder. Even hide all those planes that I'm saying. Now I can really see the ones that I missed. Again, not a problem. I can just edit the feature on this. There we go. And remember when the 3D grid system got set up, it actually created planes for me. I can use those planes inside of that feature for whatever I need to do. In this case, I'm doing bodies to mirror, so I can mirror everything that's on that side of the design. Thought I box selected those, but I guess not, so I'll just pick them individually here. And there we go, one rack. And again, it's going to start keeping track of them. If I update the cut list, I can see how many individual cuts I actually need to do. Also, remember that this thing was giving me all these miters and stuff inside of this thing. You can also use commands to trim these up. There is a trim command inside of the Weldment package. So I can pick a particular item, and then I can use either a plane or a face or something else to trim up to. So if I wanted to trim it to a particular face, I can do that. Now that's only that long. So the original trims that it does is it'll do a corner treatment, either a miter or a butt end. But if you need to slice it down, you may need to use those trim tools yourself to get this thing where you need it. All right. Okay, that one's coming up. Don't worry. This is the next one. So I want to take a little bit of a sidetrack there to show you that it doesn't need to be welded. If you want to make something out of preform or PVC, you certainly can. If you want to make it out of 2x4s and nail it together, you can also do that. So this tool gives you a lot of different things you can do. When it comes to the weldment that you're using, you see that I have a lot of nice different size, shape structures here. Where do you get the regular ones? I didn't build all of these myself. The thing is that the Weldment library that comes with SolidWorks, the reason it's so small is just to save on load time. Not everybody who uses SolidWorks uses Weldments, so to make them forfeit this much of their hard drive and spend another 10 minutes on their install loading up all these cross sections is not really great for most people. So what you can do when you're in SolidWorks, if you don't have much of a weldment choice, you can go to the design library here in SolidWorks, and there's this weldment folder. Here's ANSI inch. Here's ISO. It's got a bunch of them. It's got German, it's got Chinese, Japanese, Unistrut, British. So lots of different types that we can use. You'll see that when you select on it, it tells you Control-click will download a zip file. So what you need to do is hold your Control key, click on this, It'll download to your downloads folder. You need to unzip that and then place it into wherever your weldment profiles are. I'm going to go into the options here and show you where your weldment profiles are. Go to File Locations and then Show Folders for, and luckily most of this is alphabetic, so near the bottom we have Weldment Profiles. Okay, I am not using the default one. I'm going to add the default location, which is on your C drive under Program Files, SolidWorks Corp, SolidWorks folder, then Lang English. Here's where the weldment profiles are stored. So you want to have a folder that's just your weldment profiles to begin with. Underneath that, you're going to have different standards. Like here, I've got the ANSI standard, ISO standard, Japanese. I've got lumber, like 2x4s, 8x1s, whatever I need to do. I've even got one that's all 80-20 profiles as well. So that's the default location for your weldment profiles. It takes a second to get set up there. But now when I open up a part, like here, I've got the start of what I want to do with the catwalk that you were seeing over that big pressure vessel. So what I did was I created, some reference planes for where things are. Then I also created a surface similar to the surface that was created for me automatically by that 3D grid system. Because this is nice, I can see, okay, this is where the top of it is. This is where the tank itself is. Here's where the legs come down. So I get an idea in 3D space where this thing's supposed to be. Also, I can start a sketch right on here. Say convert entities to get the outside of the box. And then I'll just draw one of these sleepers here. It's going to hold my grating on this catwalk. Oops, you know what? I did an offset. But I should have done, I did a convert. I should have done an offset. I want to put it towards the inside on this thing. There we go. Now I'll draw that cross beam location. All right, so let's go into the structural weldments. You can see now when I pick my ANSI inch, I've got a much bigger standard to go from. Since I'm not using the default one, I'm using the ANSI inch that I downloaded from here. Let's do a piece of angle iron. I can pick the size that I'm after. So on a 3x3, a 375. When I select the location, you see it puts it wherever it thinks it wants to put that. So that vertex right there is the spot that the origin was on when they created the sketch for this thing. So that's why it's defaulting to there. But I can use different spots. If I say locate profile, I can pick any of these vertexes, or they actually put a point there for the midplane. For the midpoint. So different ways that you can say, no, I want it to come from here or there. You can run it along any point on there. So that was why I was putting that reference geometry on there. Also, the angle that this is at is important. So I can type in any value, I believe, as long as it's not negative. So I can't do -90, but I can do 270, which is the same thing. So notice it will miter them, depending on which setting you have for the corner treatment. If you don't do corner treatment, it'll just make them the total length of that line, and then you'll need to cut them yourself to get them to fit together. You can also put in a weld gap. The bigger this number is, the bigger the gap is. If it's 0, they're going to go right up to each other. Whoops. That was the gap. I thought it was my orientation. Here we go. Orientation that way. Notice that it will try to cope these to one another where it's breaking this off. It's just not very good at it. It doesn't know enough to take this fillet out of there. So a lot of times you'll have to do, if you are trying to get it exactly like you want the thing cut, you would need to open a sketch and cut that little area off of there. It's pretty easy to do. Let me hide this surface. So what I'm trying to do is just get this thing to cut midplane, but the size of that straight. I just line it up here with the actual piece that it's going to fit in there. And then when I do my cut, I can do through all, but I want to make sure that I say just cut this piece, because it'll cut through all bodies by default, but if you select it, it'll just cut that certain area. So if you want a little bit better, cut back on that. SolidWorks is really just going to do it to match the geometry. So if you have something that's a little more specialized, you may want to take a look at doing that yourself like I just did, especially before you pattern it. Also, when you're doing patterns, remember to do them as bodies. And this one is so we can do that sort of thing, pattern these. Also, let's take a look at this sketch here. I don't need to see the ladder on the sketches, but I would like to see the handrail. Turn off these planes, make it a little less busy. So you see I've got some sketches here that I sketched up for the approximate location of the handrail that I want to do and where the ladder hoops and rails are coming off of this thing. That sort of thing. Now, it is a good idea to sort of sketch this up sharp, where it's got these straight corners here, just to get all of your stuff square and correct. But in real life, I want to have this thing either be made out of bent tube or have elbows on it. So what I'm going to do is I'm going to create a 3D sketch. And then I'm going to pick this entire sketch and convert it. Now the reason I did that rather than just using the original is because at this point now I can go in here and I can put in 1-inch rounds on whatever corners I want to have bent. Doing this inside of the 3D sketch, you can do it, but a lot of times when you're getting too complex with a 3D sketch, you get things like symmetry happening, and then you try and do this, it'll just make it go bonkers trying to figure out what you're talking about. So a lot of times I just like to do it, create the 3D sketch, you know, as an overall view, and then when it comes time to create the individual pieces, instead of using this plan sketch, I'll use this converted one where I was able to round off the corners and things like that. Okay. Back under weldments, will not let you pick structural member while you're in a sketch, so I just need to exit that sketch, and then I can go ahead and start putting in the pieces of pipe that I need. So it's 1 1/4 pipe. And as long as it's a continuous line, it'll be fine with selecting this. Again, this is one of those times where you want to make the decision over whether this is going to be elbows that I'm putting in here, or whether this pipe is actually bent several times in several different directions. It's up to you by turning on this merge segments. So if this is off, what will happen is I will end up with 19 pieces. I got, most of them are just pieces of pipe here, including these little elbows. So do I want that thing to be 2, 4, 6, 8, 10, 11 pieces of weldment, or do I want it just to be one piece of pipe? Again, that is set up with this choice, merge arc. If I have the merge arc turned on, that's all going to be just one single piece of pipe. That's how I was able to, build these things. If we take a look at this finished weldment, it's got a lot of stuff going on. As far as the cut list, most of this is, pipe or L bracket, but there are pieces of sheet metal. So I can get a flat at any time for any of these sheet metal parts. It's really a nice, design tool for me to put everything in one shot. If we are having a big system like this, it's nice to have all of the things together. So I've talked about patterning and mirroring and things like that, and I definitely do want to take advantage of them as much as possible. Let me open up this part here. Talk just a little bit about it. So it's quite an in-depth cut list. Most of this is all just pipe. There is a big sheet metal part down at the bottom here. But let me go to before I started trimming and mirroring it. So I only built 1/2 of this thing. Of course, when you have items that are created with the same tool, they will trim up to one another. But if you have them from different features or things like that, they will not trim to one another. Or if they're a different size. They're going to be in a different feature, so they're not going to trim to each other. So you see these things are the total length of the part. The trim tool inside of Weldments, the way it works is you pick the part you want to have trimmed, and then you can have it either go up to a facer plane or up to a particular body. It is a, you see, trim/extend, because it will do either one of them. It'll take a look at what it's supposed to have, and it'll figure whether it's supposed to remove material or add material to get to that. You can put weld gaps in here if you need to step it off a little bit, but you can get it to extend or to trim to one another. You do want to be careful as far as how much stuff can be trimmed at once. Sometimes you may need to do it in a couple of steps. A lot of time, the issue that you'll run into when you're starting to use multiple pieces to cut and trim with is sometimes it gets confused as to whether it's supposed to be extending things or whether things get cut with at strange angles. Sometimes you'll have, use a cutting tool over here and it'll start trimming something over there just because it's extended that surface indefinitely. So you do want to be careful when you are trimming, what does it keep and what does it throw away. If I go back into this feature, you'll see that it'll usually put a keep or discard item next to what it's going to keep or discard. So you can toggle it. If it got it wrong, you can tell it, no, I want to get rid of that section of pipe. So the trim tool, usually if you're doing a structural member and you're doing a bunch of groups, they'll all trim to each other. But if you're doing separate groups or it's just something where they're not going to allow you to trim to one another, you can do it manually with this trim extend tool. You can also do it with just a regular cut, but the trim extend tool is nice because it's a parametric form up to the next body, so it'll update a lot easier than the usual cut will. The other thing I want to talk about before I leave here is symmetry. So this is only half of a car. It's going to be problematic. I need to have two sides of the car. So there's two different ways that we can think about this. There's some that are going to be mirrored where I want them merged and some where they're mirrored and I don't want them merged. So if I go on to my mirror command, I pick my midplane, I want that to be one piece. These also are going to end up being one piece when we're done, hopefully. So I'll pick all those items that are actually the body size is going to double. And to do that, you have to have this merge solids checked on. When that's checked on, what it'll do automatically is it will merge the bodies. But it's pretty smart about it. It didn't merge this one into this one. They stayed their own pieces, where if I isolate this one, it's not connected to all the rest of those pieces. It just merged at the point that it touched itself. So when you do the merge results, what it does is it'll give you twice as long of a pipe, basically, like this one here. Used to only go to the mid plane, but I told it to mirror, and now it's one single piece of pipe for the cut length. The other types of mirrors are things like, my mid plane first. The things that are only happening on one side of the car. So these pieces here that I'm selecting, I don't need them to merge with one another. They're actually going to be their own independent pieces. So merge solids is turned off by default because the weldment tool is on. But there we go. Now I've got, this is its own item compared to this one. It does not merge them together like it does when you're trying to double the size of the pipe. Okay, so that was my seminar on weldments. Hopefully you guys got some tips or tricks that you can use in your design. As always, if you have any questions, you can contact me, or you can take a look at that website, go/x-mechanical, for any of the videos that I've covered on any of this SolidWorks series. All right, thanks everybody.